I'm Pat Dugas, and this screencast is about solving quadratic inequalities. The process of solving a quadratic inequality is very similar to that of solving a linear inequality. You're going to graph the related equation, and by related equation I mean turning the inequality into an equation with an equal sign and then solving that. Now with quadratics it's a little bit more complicated. You might have to use the quadratic equation or factoring or some other method. You're going to find the solutions to that which represent the boundary of the inequality. Then you're going to pick a point that is not along that boundary. It's outside the boundary. You may have to test multiple areas. Depending on the results of that test, you're going to then shade the appropriate region or regions. We're going to look at two examples, one that's a two-dimensional example and one that's a one-dimensional example. We'll look at the two-dimensional example first. So here we have two variables, y and x. We're looking for the solutions to y greater than x squared minus 3x plus 2. So we're going to graph the related equation. We're going to turn this greater than sign into an equal sign and then solve this equation. And we're going to graph that. When we graph it, we get the parabolic shape of the quadratic. And since it's a greater than sign, we're going to use a dashed boundary. If it was a greater than or equal to, we would use a solid boundary. Again, just like linear inequalities. So we're going to test a point that's inside the parabola, or it could be outside also, but in this case we're going to choose the point 1, 2. And we're going to test it. And by test it, of course, that means we're going to plug in a 1 for x and a 2 for y and then see what happens. Well, what happens is we get 2 greater than 0, which is a true statement. Since that's true, the point 1, 2 is going to be in our inequality. So testing that point 1, 2, 1, 2 turns out to be a true statement. Therefore, our solution is going to be this area inside the parabola shape. So shade the appropriate region. That's going to be this blue shaded area. Any point that lies within that blue shaded area, but not on the boundary because it's dashed, is a solution to this inequality. So that's a two-dimensional inequality. It's often easier to test the point 0, 0 if you have that choice. In this case, we would have gotten 0 greater than 2, which is false, so we would have known not to shade the outside region. Again, you can pick any point you want as long as it's not on the boundary. Let's look at a one-dimensional quadratic inequality and solving it. And this one may wind up being a little bit more complicated. We're going to solve the inequality 0 less than or equal to negative 2x squared minus 6x plus 1. One variable here, so it's going to be a one-dimensional solution along a number line. So we're going to use the related equation, negative 2x squared minus 6x plus 1 equals 0. And we're going to find the roots or solutions to this related equation because these are going to be the boundaries on the number line that will divide it up into intervals that we have to test. And we know since it's a quadratic, there could be either 2, 1, or 0 solutions. Okay, so we're going to write that related equation. This one doesn't factor, so we're going to use the quadratic formula. And again, you can always use the quadratic formula on any quadratic. It's going to work every time. It's just a little bit more complicated. That's its downside. So you may recall it's negative b plus or minus the square root of b squared minus 4ac all over 2a. We're going to identify the a, which is negative 2, the b, which is negative 6, and the c, which is positive 1. So we're going to substitute the appropriate values for a, b, and c into the quadratic formula. If you need more work on that, there's a screencast on the quadratic formula dedicated to it. When we do that, we get positive 6 plus the square root of 44 over negative 4, or 6 minus the square root of 44 over negative 4. Okay, those are both irrational number solutions. There are two irrational solutions to this. And when we crunch that out on our calculator, you get x is approximately negative 3.16 and x is approximately 0.16. Again, they're rational numbers, so they are an approximation. We just chose to go to 2 decimal points here. Those become the boundaries on the number line. So you plot a number line. Here's the point x equals negative 3.16. Here's the point x equals 0.16. The solution is going to be some combination of numbers within any of these three intervals. So we've got an interval here, an interval here, and an interval here. We're going to pick points inside each of those intervals, not on the boundaries, to test. Okay, so we're going to test values on each interval against the original inequality, negative 2x squared minus 6x plus 1 greater than or equal to 0. Notice that I've turned the inequality around because I think most of us, we tend to like having the variables on the left-hand side, especially when it comes to inequalities. Of course, that does flip the direction of the inequality when you do that. First thing we're going to do, we're going to look at this far left interval, x less than negative 3.16. So we'll pick a test value for x. It's got to be to the left of negative 3.16. Negative 4 is a good one to test. When you put in a negative 4 into this inequality, you've got to be really careful with negative numbers, of course, as always. Over here, you're going to get negative 32 plus 24 plus 1, and that's supposed to be greater than or equal to 0, but it's not, because this is negative 8, this is negative 7. You get negative 7 greater than or equal to 0, which is false. So this region is not part of our solution. So we're going to test the middle region between negative 3.16 and positive 0.16. I always try to pick 0 if I can, because it's such an easy number to work with. 0 is within this interval. If I put 0 in put a 0 into x until I test inequality, I get 0 minus 0 plus 1 greater than or equal to 0. We get 1 greater than or equal to 0. That's true. So this interval is part of our solution. We need to test the right-hand interval as well. X is greater than 0.16, and I picked 1 because it's a nice, easy number to work with as well. So when we put negative 2 times 1 squared, or negative 2, minus 6 times 1, plus 1, or we also get negative 7 greater than or equal to 0, which is also false. So this region is incorrect as well. So now we shade the appropriate interval, and down here at the bottom I've done that. The only interval that works, that the solutions are, is between negative 3.16 and 0.16. Now, the endpoints are included. They are solid because this is a greater than or equal to or less than or equal to inequality, because the endpoints are part of the solution. And so that's solving a quadratic inequality in one variable along a number line. So we've looked at solving quadratic inequalities. The process is very similar to that of solving linear inequalities. It's just that we often have more solutions that we have to test.